Being recorded now. Sorry.
So, ready, Jonas?
Yeah, thanks out for the great introduction. And yeah, let's skip right to our topic, which is scaling your infrastructure up to the first 10 million users. And yes, we agree that the title is quite catchy, and some of you might be because of it. But actually, we are going to talk about this. And as I have only about 20 to 30 minutes slotted for this, you can assume that I will only be able to gloss over many of the great AWS services and architecture considerations that you have to make. So I'll basically tell you about main steps and in your application scaling journey and how your typical AWS infrastructure should scale under AWS recommendations. And where do we start? Well, we start with AWS global infrastructure. And why is that? Because you have to take advantage of it. It has 26 regions. Every region has geographically isolated multiple availability zones. It has over 300 edge locations all around the world for your content distribution. And all of these parts are interlinked one with each other via AWS backbone network that provides low latency anywhere in the world. As well, it reduces your server load. But yeah, let's get back to that architectural considerations. And as you may know, each problem has many solutions, and there's no single truth or sequence to follow to get there. So you might start with a more sophisticated architecture already, or you could skip several steps, or you can go back and implement something that you might have missed. And the beauty of the cloud is that every decision is reversible here, and that and basically you shouldn't be afraid to innovate, change, test, and do agile implementations. So what you have to choose from? Basically, there are two types of services available in AWS. One is basic DIY stuff that you can actually build yourself. It's not managed. You have to manage it. You have to patch it and make it highly available and scalable and secure. So these would include Amazon EC2, block store, RDS databases, virtual private networks. But there is also another like set of services, which is called fully managed services. Those are built by AWS, managed by AWS. They are secure by default, scalable, highly durable. But there is one caveat that you have to play within the rules and constraints of those services. And also, this might lead to a vendor lock-in. Yeah, there is also a possibility that AWS pre-built service might not be the right for you. But we always recommend to give them a try them out, test them, and see whether it suits your workload. As I briefly mentioned, you shouldn't be afraid to test and implement new stuff in the cloud. You should be able to learn, build, then measure your infrastructure and repeat the cycle all over again. So your infrastructure will change as your business grows. Okay, let's get back to your journey. And so your scaling begins. And let me just congratulate you because your application is going to be super popular. It's the way day one at the office, and you as a developer launch your application in the cloud. Basically, you have an instance, a web server. You attach a external IP address via Elastic IP address. You host your fancy domain name in Route 53 And as well, you create another server and host a database in it. Scaling currently might seem far off on the horizon, and your app is going to rock, I promise. But you want to be prepared for that, right? So let us see what's waiting for you ahead. Unfortunately, with great fame comes a great responsibility. And actually, being in the cloud, you have to know how to scale, how to meet the not only meet the demand, but actually be ahead of it. So it's your job actually to make sure that your clients always have the best experience, so they associate you as a good service provider. Okay, so how to scale? Us being a technical people, what we do when we don't know, well, we go to Google and type some keywords, and if we type scaling on AWS, yes, the first 5 results point to auto scaling, so this might be it, right? You just go to auto scaling, turn it on, and take your CTO or DevOps hats off, and yes, you're done. Congratulations. However, there's no single button or magic dial to turn in the scaling journey. You have to do a lot of work, think through architectural considerations when it comes to really high volumes. And that's what we are going to talk about today. So if the solution is not auto scaling, then what is it? And the first thing that you're going to notice in AWS is that there are many available instance types, instance family sizes. So which is the right one for you? The good news is that you don't have to know every one of them. And the beauty of it is that you will find them when you need them. There are instances for IOPS, for dedicated storage, attached dedicated storage, for more CPU or more RAM or different architectures such as ARM. But yeah, actually, what should you choose and how big? And I will give you an analogy of online shopping, which I love. So basically, it works like that. You pick up 5 different things, 3 sizes each, order them, they get delivered to your door. You unpack it, try it on, see what fits you best. Perhaps this is 1 or 2 t-shirts or pants or whatever, and you pack the rest into the same box, put the sticker on it, and just send it away. Basically, it's pretty much the same in the cloud. You try different sizes and families, you monitor the performance, and actually, I suggest you to go straight ahead and real with monitoring from the get-go. So you have that data and you have the knowledge how to monitor correctly. So you monitor it, you stick with the ones that fit your application best. And the one thing to note actually is that with the bigger instance size, it brings only diminishing returns. So you will hit a top where bigger instance will not, and bigger costs of that instance will not yield you more additional benefits. Okay, let's get back to our first architecture. As you see, there's no redundancy. There's this single instance. It's not highly available. It has nowhere to fail over. And so if it fails, well, your application is down and your users aren't happy. Well, single user. Okay, but what about the database options? Can we improve them? Yes, of course. As you see, we have on the left, we have the self-managed database hosted on EC2. It's like a DIY approach. But as I said, you have to manage it, back it up. It takes your time away, which could be much better spent building your application. So AWS has pre-built several fully managed database services that you can choose from, like Amazon RDS and Amazon DynamoDB, Amazon Neptune for graph databases, and so on. And even if you already have a database, move it over to RDS or Aurora. There are AWS tools here, so you actually can be on top and use the best AWS services. And I don't know, decades-long question is to NoSQL or not to NoSQL. And our simple recommendation is to actually start with RDS. And the advantages are very clear. It's simple to set up. It's very stable. It has been here for decades, and developers are very familiar working with it. And you are good with SQL solutions hosted in AWS for your first million users. So you actually don't have to do NoSQL dance very long in your scaling journey. Cool. You have 100 users. You implemented some changes. You have an Amazon RDS instance running here. And your architecture looks something like this. But what about 1,000? While preparing for your first 1,000 users, you take it seriously. You make your architecture resilient and highly available. So remember, I talked about those availability zones, so geographically isolated data centers of AWS. Well, it's time to use them. You actually use at least 2 of them. You clone your web server to another availability zone. You put a load balancer in front of them, so your requests would be balanced. And as well, you go into your RDS instance. You just tick a checkbox to make it multi-AZ, and bam, you have a primary database and a standby replica that is your secondary database. And in case of failover, your web server has another instance to fail to, and your database has also a standby copy. So you're balancing requests, there are 2 servers, active passive database, and everything looks very nice. So let's get back to the methods of scaling, and we already touched the vertical scaling, so it's a bigger box approach. It's called also scaling up. And it's not wrong to do that, don't get me wrong. There's little point to use hundreds of tiny T3 micro instances and manage them separately, while you're better off with several bigger ones, extra large boxes. But when more power is needed and you're expanding to other availability zones, scaling with similar sized instances horizontally is much more preferred. And this approach is taken seriously when we go and approach about 10,000 users, and well, architecture doesn't change much, but we are starting to use more instances and that are behind the same load balancer. The RDS is starting to choke a little after those 10,000 users requests. And yeah, remember, there's this single only database that's working. This one is just sitting idle. So it's time to take some care of that database. And what we do, well, we create read replicas. And read replicas are copies of the primary database that are meant to only do read-related requests. So in order to achieve that, you have to go to your application, edit it, change your code, so you can actually separate which requests are only reads and which requests are only writes. So the writes go back to your primary database and the reads go to your read replicas. And all seems under control for now. Let's shift some load around, and as you see, we have 2 new services that we want to employ. First is Amazon CloudFront. It's a content delivery network of AWS. It uses those 300 edge locations that I talked about. Actually, it's used for hosting the static content. For example, the one you can host in S3 buckets. S3 is highly scalable, durable, infinite scale storage where you can put your objects. But CloudFront does not only serve static content, but if you see here, your users can come through CloudFront, through load balancer, to your instances, and get back. So actually, even the dynamic content is also accelerated because it's going through AWS backbone network. Let's shift some more load around, and what else can we improve? Actually, there is one thing that never changes. There are some repetitive SQL queries that always happen. For example, when you load a page, some queries are issued to database, and they're always the same. And the solution to mitigate that is to actually have cache nodes. And cache nodes in Amazon Elasticache allows you to cache some SQL queries, which are very repetitive. And so the instances will not go to RDS instance and ask for that information anymore. It will go to the cache nodes instead and receive that request, answer to that request in single-digit milliseconds. So you improve the repetitive SQL queries. Let's shift some more load around. And as you see, I've talked about the going with SQL, but here we have the DynamoDB. It's a NoSQL database. It's fast distributed and very scalable. And we can even make use of global tables, which replicate worldwide in under 1 second. It's really powerful service. It can host pretty much everything, well, in NoSQL manner. And to move data between RDS and NoSQL, we use AWS Database Migration Service in conjunction with the Schema Conversion Toolkit. So they both are very powerful. And once you have the need to move some data out of RDS, there is always a way to move it into NoSQL. So that is why we recommend you to start with RDS and only later move on to the NoSQL. So now that our web load is distributed to other services, let's revisit where we started. So it's the auto scaling. And you could have just started with auto scaling, yeah, and right from the beginning. But I just simply wanted to show you how many other approaches there are for you to take advantage of to scale your infrastructure. Well, how the auto scaling works is pretty simple. It anticipates the demand, it tracks your instance fleet load, and then it simply regulates the fleet size, which is dealing with those requests. It balances across the availability zones, and basically it's very convenient and cost-effective solution to scale up and down your compute needs. And at 500,000 users mark, we actually start implementing auto scaling. We create an auto scaling group. Actually, it was a lot of work to get to 500,000 users, but this infrastructure is now enterprise grade, and it should be able to cope with such number of requests. With 500,000 users, actually, you as a single developer, you are starting to need more help and in more hands to maintain your infrastructure. So you'll take a look at the automation, and the first one that we would recommend is the AWS Systems Manager, which automates your operational tasks, such I don't know, storing secrets, running scripts, doing patching. It's basically your systems manager in the cloud. So I would really recommend you taking a look at it and perhaps hiring it. Infrastructure automation goes a long way, and I can mention several of them. You can actually use and orchestrate containers with Amazon ECS or EKS for Kubernetes, run them on EC2 instances, or perhaps running on AWS Fargate, which is fully serverless containers compute engine. You can treat your infrastructure as code with CloudFormation, or you can program it with AWS Cloud Development Kit. So there are many ways that you can do more with less. So with 500,000 users, you should be very serious with your monitoring and logging. You have to measure feedback from your customers, find areas to improve. So, for example, the CloudWatch comes to mind first. It collects metrics and logs. Metrics and logs that you monitor. It can even act on events and analyze trends. And a good example of that is CloudWatch alarms, which, for example, can be issued when it finds an anomaly. It creates an alarm, and it can have an action attached to it when that alarm happens. Okay, so we have talked about the infrastructure as a whole, but now let's get back to your actual application. So you have built it, and what's next? Well, now we break it apart. It's time to learn some more new words. It's SOA, and we go to Google, of course, and Google it, and it means that it is a service-oriented architecture. But actually, question still is, what is it? In a nutshell, it is an architectural style that supports orientation into services. And service actually is a discrete unit of functionality that can be accessed, maintained, scaled independently. So basically, you just break it down to smaller pieces. Serverless applications can help you deal with that service-oriented architecture. I can mention several of those. For example, you don't have to maintain your API gateways because it's already built by AWS. You can use very robust notification service and queue service, and have step functions to control AWS Lambdas, create workflows with them. You can send emails to your marketing contacts, etc. And another way that goes hand in hand with SOA is loose coupling. So this is an example of it. Here we have a request that publishes its request information into SNS topic, a notification service topic. That topic is subscribed by this queue based on SQS service. And then the worker nodes go to that queue, get that message, process it, put the result back to the queue gets it back to the topic, and the topic sends it back to the requester. It's a very reliable solution because SNS, SQS are fully managed by AWS. You don't have to think about the infrastructure that's underlying it. It's very secure, it's very scalable, and basically you don't have to invent your own services just to make use of them. Event-driven compute is also part of SOA. Actually, there is this thing called Event Bridge, which captures many services, many AWS services events, and can route them to other services or act on them. For example, when you put something into S3, it can issue an event that can be processed with the AWS Lambda, or Lambda can be attached to DynamoDB streams that result in new additions, edits, etc., and many other, for example, CloudWatch alerts that can be processed with Lambdas, etc. And the microservices architecture, after a while, might look like something like this. And yeah, we propose to make it better, and now look at this mess. It's not very convenient or understandable what's happening in there. Frankly, AWS has some tools that help you to make sense of this whole mess. And it helps to identify the performance and bottlenecks and errors. And AWS X-Ray works in such a way that it tracks the requests and tracks the whole path of the workload operation. And it even builds a map where you can actually see which parts are less performant than others, which parts are lagging behind, so you can actually take care and fix only those parts. Those are the microservices that can scale independently, and you can actually reshape them, change their architecture or way of them working. So it's a very powerful approach. So that's some high volume. It's I think it's only the only viable approach. And when we come to 1 million user mark, let's reiterate what we have done. So we employed multi-AZs. So we have our working nodes, web servers, databases spread across multiple AZs and possibly even regions. We are distributing our request through elastic load balancers. We are using auto-scaling to scale our working fleet. We're using SOA, and we broke down our monolithic application into microservices. We're serving our content through Amazon CloudFront, utilizing S3 for static content. We're caching the database in Elasticache, and we're moving state of tiers that auto scale. So at 1 million users, our application is getting a bit interesting. What are the changes? Well, basically, we added the worker auto-scaling group. We had this before. We also have an internal network, internal load balancer. We are employing CloudWatch, sending some emails through SES. We have SQSQ that works with Lambda and S3 buckets. Also, there's a DynamoDB table with some context that lambdas that are reacting by the input to DynamoDB table. We have an API gateway launched that actually allows external users to come into our application. The next steps, going to 5 or into 10 million, basically are constrained in one particular part that's not performant enough. Most often it's database, and there are several potential solutions. The approaches are not very easy to explain in a minute, but one of them is federation. So basically it is a splitting your database into multiple databases, and each database has its own function. For example, one database could be for users and inventory, and another database could be for transactions and orders. And your queries should be routed accordingly to the database that stores that data. Another approach is called sharding, and that one would split data according to some indexes, and there would be an index database that would tell your query where to go next, to which database that holds the right information. So to quickly review, we made our multi-AZ infrastructure. We're using self-scaling services, which are fully managed, like application load balancers, S3, Lambdas, SNS, SQS, AWS step functions, and others. We have redundancy built in. We have started with SQL and then later improved it with shifting some load to NoSQL. As well, we can actually work more with SQL and apply those two principles that I covered in the previous slide. We're caching data both inside and outside, and using our automation tools in our infrastructure, such as infrastructure as code or Systems Manager. As well, we are making sure that we are very robust monitoring. It helps us a lot. We have split our monolithic architecture into service-oriented architecture. We're using auto-scaling. We didn't reinvent the wheel and using AWS services and not building them by ourselves when we don't need it. And yeah, we moved to NoSQL when it makes sense. And the journey to 10 million plus users is actually without a cap to infinity. But actually, don't quote me on that. It involves fine-tuning of each of your microservices because the load is getting this just huge, and you have to use the X-ray and other tools to measure the performance of the request route through your application architecture. You move more to SOA, split those microservices even to smaller parts and scale them independently. You're moving also to multiple, not only multiple availability zones, but multiple regions and start replications right there. You are starting to look into building your custom solutions. Well, this is the part where I mentioned didn't reinvent the wheel. When you're 10 million users, perhaps some parts will not work as you anticipate, and you will have to actually build something on top of AWS. And yeah, you have a deep understanding of your whole stack, and you employ serverless solutions whenever possible, because the burden to maintain those services by yourself would be too much at this scale. And last thing is, yes.
We have a question for the 10 million user slide, so I guess it's a good place to try to answer it.
Sure, should be.
So I'll read it. If you plan to hit 10 million users in a new app, would you architect it right away for 10 million? Or would you still start with a monolithic approach, given that there's no restriction with budget, resources, or timeline?
Actually, my solid answer would be to start from zero, or start it like a normal application, even though you think it will scale to 10 million. Because as I said, you can always change your decisions in the cloud. You can rebuild your architecture. The thing is that 90% chance is that the architecture you will build for 10 million users for that application will eventually will be changed without recognition to the first infrastructure you built, because the requirements change, the application workflow changes. Perhaps it's even purpose sometimes changes. You add some logic to it that was never meant before. And yeah, short answer is go this tried and trusted route, build from small things, start at the bottom, work your way up, and yeah, improve along the way. Be agile and don't try to build enterprise with 10 or 100 users. I think it's not worth it, and it will eventually change. Yeah, let's get back to the last slide of my presentation. I wanted to give some honorable mentions to AWS. It's exemplary documentation. It's reference guides to architectures, to well-architected framework that Odd talked about and we do reviews on. Also about the solutions that you can employ, install into your environment with the CloudFormation templates. Those are created and curated by AWS. And also Quick Start, which has some industry verticals related Quick Start guides, so you can actually prepare your AWS infrastructure and environment to get up to speed real quick. And also don't forget that you can actually try Amazon Web Services for free. It has, I think, the broadest free tier of all the clouds. You have 12 months to try it for free with much of the functionality available to you. And if some parts are not free, well, they're not very expensive to add on top. And that's it from my part. We can actually go to our Q&A. And
luckily, we had somebody already start, but okay, Alexei asks or says, not a question, just a thing that is worth mentioning, costs. AWS provides a lot of really good services, but everything comes at a cost. I guess that's life.
yes, I think running business always incurs some costs, but my suggestion would be always to have an understanding of how much that solution would cost you to run. There are calculators available to do that, to approximate your spending as well. You can actually always go to different cloud providers' sites and try comprising your architecture from their services and see whether there is a big benefit to go to other cloud provider. From our experience, we see that when clients come from other cloud vendors, we see around 20-30% less expenses in AWS. But yeah,
very important to note, when the infrastructure is optimized, then it's when you get the savings. And
it's even more savings.
Yeah, I would also like to add to this that AWS likes to throw a lot of money to startups, especially during the beginning years. So that's also something we can help with. Main thing is just get in touch with us, and we can guide you through the whole world of AWS, of the credits and versions of products, etc.
That's correct.
But next one, question was, I wanted to ask, when is the right time to start thinking about CDN solutions in a startup?
Yeah, really simple answer. I think once your user base is getting more and more spread around, because at first you will build your infrastructure close to your initial starting area. So those requests can actually be served from your main servers. Yeah. So once the user base starts to spread around and you need more and more different locations to reach your users, then it is very high time to use CloudFront. As well, if your application is quite localized and it uses users are quite not that spread out, but their volume is increasing substantially, for example, 10,000 and more, then it's also the high time to start employing CloudFront, because you will provide your users with better experience. They will have lower latency reaching your static and even dynamic content through AWS backbone network. So there are like two answers. One is when your local user database expands, and second, when your user base expands geographically.
Now, next one, we'll keep them coming. What are the common mistakes during scaling where developers choose the wrong settings, thus unnecessary increasing cost?
There are many mistakes where they choose to save costs, but where they, I wouldn't say there are many such mistakes that would increase costs substantially. Because, for example, if you would take containers, you can run them like an IDEA by eye approach. It will be, let's say, price X. Then you can pack them within ECS and run them on EC2. It will be a bit more expensive, like 10-15%. And then you can actually run them in Fargate and forget about EC2s completely. And that would, for example, raise your bill around 30%. But you don't have to worry about the EC2, about its security, scalability, patching, etc., etc. So every decision has a price. More convenience has bigger price. But actually, I don't know. perhaps one mistake that developers could make is that they would assume they are global too early, and then they would have some geo-replication going on of their S3 bucket static content spread around the world, DynamoDB global tables turned on for whatever reason, having DR sites. Well, DR sites are good to have, but too many of them. So perhaps these would be
maybe one from a sales side that we see all the time is that the underutilization of reserved instances, which is the very basic thing how you can save cost, but they are not used. So that doesn't mean that your cost is increasing, but you could be paying less.
Yes, these are saving measures that can also be employed in your scaling journey through reserved instances or savings plans. That is, these two are very good options to lower your bill. And yeah, perhaps one more thing about those costly mistakes, I would say, yeah, as Ott briefly mentioned, it's right sizing. Don't have too big of instances that you don't use. For example, you can have like too big of a auto-scaling fleet working with your requests when you could have like 2 instances running in each AZ, and you have like 6 for, I don't know, whatever reason, anticipating some load. But that's why auto-scaling is built for. So it anticipates the load and scales your infrastructure. Yeah, for example, too big of database instances and your load is very peaky. It peaks once a day for 15 minutes and you are having your big database always running. That's not good use of money. Why not go to, for example, Amazon Aurora Serverless, where it automatically scales and you don't have to actually worry about the instance size at all. When it's needed, it scales up, it scales down immediately after the load is done. So perhaps these approaches are also valid to mention.
Very good stuff. Now we have one more unanswered. Jonas, what service would you recommend for business metric gathering in serverless? In non-serverless world, you have Prometheus, where it comes in scrapes, accumulated metrics periodically. What would you recommend for serverless when you're operating at such a huge scale?
Well, yeah, in server world, you have the Prometheus, you can gather many application metrics. But yeah, as I mentioned, several of the AWS managed services built for SOA, like X-Ray and several others, we can actually dig into it and provide you with a longer list of them that help you look into your architecture and your application workings from the inside, so you have a better understanding of which parts are performed and which are not. And yeah, but basically I think the main point of entry for those parts to monitor the serverless stuff is Amazon CloudWatch Event Bridge. It gathers, it's connected to those services. It can have it logs their activity, and you can actually keep them, analyze them, act on them. So I think that's the one service you might look into it. Ott, you're in mute.
Cool. Yeah, I saw it. Luckily, Zoom tells you that you're.
What are you doing?
So thanks for the questions. Thanks for the answers. If there are any more, just you have a few more minutes. But if there aren't, then thank you, Jonas, for the cool presentation and the insights. I hope it was well worth everybody's time who came and sat in. And now to finish, once more, everything that you were asking about, we can actually take a look at individually within the well-architected review proposal. So as mentioned before, you can use the form to fill it out, and then we'll reach out to you and schedule a sit down, maybe with Jonas, maybe one of his colleagues, to carry out the well-architected review, and also we will fix the issues that we come across during the review. So maybe one more sentence, The review is actually created to identify and mitigate risks before they become a problem, and build a consistent methodology for quickly deploying applications on AWS and make the necessary changes to help you also scale the business. So yeah, we pasted the link here there again. Feel free, and we'll get back in touch with you shortly and set it up. And that's it. So
Yeah.
I see that there's no more questions, no more Q&A stuff. So thanks for being with us today. Anytime you feel the need or feel that you would like to hear some other thoughts or 4i concept, somebody else looks at your thoughts on how to do things, feel free to reach out to me, Jonas, anybody else in Cloudvisor, or by email or by LinkedIn. And I think next slide should have our emails as well, but it's very, very easy to find our contact details.
I'm afraid that it's not an option now.
Okay.
It's Jonas at CloudWatch EU and
same,
at CloudWatch
same
EU.
for me. Yes. So yeah, thank you, Jonas, again, and thank you everyone for attending, and looking forward to your to meeting you on our next events. So
yeah, guys, I hope you learned something new that you will employ in your architectures and applications. Yeah, I had a great time. I hope you too. Pleasure is all mine. So I think we'll see you in next webinars soon.
Okay, everybody. Bye.
Okay, bye.
Now